Hey everyone, welcome to the data science speaker series. So today we're going to have actually a longtime friend of mine, Will Hawkins, speak. Will Hawkins is currently a senior data scientist and mentioned that he's going to be sharing his journey from studying a seemingly unrelated subject and heading towards this world. So Will, take it over.
Yeah, thanks, Sean. It's an honor to get to talk tonight. And I love San Francisco. I currently live in Indiana, but I get out the Bay Area a couple times a year, and it's one of my favorite places on earth. So yeah, a little bit about me. So I live in Indiana. I work for a consulting firm, so we're a smaller group. We're called Keller Schroeder. Employee owned. We have about 100 employees. We've got four groups. We've got applications, which is exactly what it sounds like, custom software, data strategy, which is the group that I'm in. So it's everything from helping organizations come up with like a 5-year corporate data strategy plan to like kind of operationalizing that, which is more what I do, like the data science part. Then we've got infrastructure, which is like selling hardware, routers, your kind of IT commodity stuff. And then we have a staffing group. But my background, I'd imagine that like on this call tonight, we probably have a pretty diverse background of people, maybe some people that are like fresh out of high school, in college for the first time doing data science, probably some people in my boat where you kind of had a career and are wanting to get into data science and, taking classes to further that. So my background is actually in exercise science. So like Sean had said, kind of a seemingly unrelated field. So in undergrad, which is actually where I got to know Sean, I studied exercise science and I thought I wanted to be a physical therapist. And at some point decided that that wasn't really for me. I had done some internships and had some jobs where I was working with professional athletes, basically helping them to further develop into better athletes so they could, get drafted and so on and so forth. And at some point in that process, I determined that really what interested me was kind of the research side of physiology, rather than being like a physical therapist or a practitioner. I was really interested in like, how do you study the human body? Like we all know that if you eat healthy and like sleep more and drink lots of water, then, you're probably going to get more healthy. But okay, how do we study that? How can we find out which of those factors is most important? How can we figure out how to like optimize training, nutrition, those types of things? Started to really interest me. So I went on to do a master's degree and eventually a PhD in that. And after my PhD, I was a professor of biology for 3 years and made the transition into data science 3 years ago. So why the career pivot? And again, like I have absolutely no doubt that there's people on this call right now that are like looking for their second career. So, maybe these are things you are experiencing for yourself, but, for me, I was, a research professor. I was a tenure track professor, but, I kept feeling like the research I was doing wasn't really being like turned into product or, I was writing all these papers and like 20 really smart people were reading them, but like they weren't actually like changing the way people, exercised or the way people ate or any of these things. Like I didn't have a company that I was, helping bring these optimal practices, to the world. And really, I started to see like the part of the whole research cycle that I really enjoyed was really the kind of what do you do once you have all the data. And so, and that's basically like statistics, coding, and then disseminating your findings. Like how do we draw applications from a huge data set that we collect? Some other reasons, I felt like I was kind of doing the same thing every day. And if that's something that you're absolutely in love with, then that's great. But for me, I really wanted to, be building things and helping companies build things. And then cultural fit, for whatever reason, I've just really liked the data science consulting world a lot better than I did the academic lifestyle. So those were like the main factors for my personal kind of pivot out of my previous being a professor life into my current gig. And so how did I make the jump? So obviously data science, again, it's kind of like an umbrella term. Like as you get to the point where you're applying for jobs, you'll see the same job like data scientist, and then you'll read the job description and you'll see like kind of a wide variety of things. Like a lot of companies will get like data analyst confused with data scientist, and how do you juxtapose that with like a machine learning engineer or a AI engineer? So I think that for me, my journey really started during my PhD program, when I started taking statistics courses and coding courses. And so I took a couple courses in Python, and then like my first statistics course was biostatistics. And I wasn't someone who like really loved math growing up, but something about like being in that context of, I've got my data set. I spent all this time doing this research. I collected the data myself. Something about like that ownership and obsession with like the question I was trying to answer really kind of set me up to start really enjoying some of those statistics and coding classes. Like I found that like once I kind of got into the context of data science, I started really enjoying math. I started really enjoying coding. And so like, how did I pick up some of those skills along the way? So data science, I think part of it is gifting. Like I do think that if you're highly analytical, then something like data science is going to be great for you. Like if you find yourself kind of analyzing process naturally, trying to naturally find trends in your life and in the world around you, like I think that is a gifting, and probably sets you up to potentially be a good data scientist. I think undoubtedly the work, and all of you agree because you're in school. So I think that especially math, I think that that you can learn kind of like the Python and SQL side of like the coding side fairly easily in like an online boot camp. And become somewhat proficient through those types of things. But I haven't found as many coding boot camps that are really good at teaching the math side. And so like for my personal development, most of the math I know, I have learned in grad school. And then like career experience, that helped me to think quantitatively just from, being a research professor, really understanding that whole research cycle. And then circle of influence, just being around other quantitative thinkers, other researchers, they really, pushed me and helped me to sharpen my skills. So I talked a little too much on that slide. So to me, there's like 3 primary technical skills: be a good data scientist, math, coding, and then some sort of business acumen. Depending on the industry or company that you want to be a data scientist with, you're probably going to need to understand like some parts of that industry. So I don't know, if you want to work for like a huge business to consumer sales company, you're going to need to understand different like KPIs or key performance indicators like customer churn. Okay, what is that? That's once we get a customer, how long until they leave us on average? So, just things like that. So I think those are the three kind of primary skills that I have found have been really important as a data scientist. Okay, so again, like I've only been in data science 3 years. I became a senior data scientist like 2 months ago. So I'm like still pretty new to the game. What was I prepared for? Honestly, I found that my coursework in grad school really prepared me technically. Like I think any math classes you can take, especially statistics, obviously. So, really understanding regression, different forms of regression. I think clustering is another just kind of general data science skill set. Then obviously, depending on the company or industry, there might be some like very specific parts of math that it might be helpful to up your technical skills on, but really I haven't been like constantly hit with problems or technical issues that I don't feel like I am able to figure out. Internal culture, if you're getting your first job in tech, fresh out of college, then you're not really going to know a different culture necessarily work-wise. But I have found data science to be like pretty fast paced. And then adaptability, like I think that's one of the biggest things that I've seen amongst successful data scientists is a lot of times problems you're trying to solve are fairly ambiguous. And a lot of times I see data scientists aren't given like tons of, advice or suggestions on exactly how to solve the problem. And so I think being someone that's naturally adaptable is super important. Some things that I found that I wasn't necessarily prepared for, like given my background and my kind of transition pivot into a new field was so IT development frameworks. Like you can be a really great coder, math, absolute all-star, but understanding things like agile and Git, like how do companies do version control? How do companies distribute work amongst teams of engineers and scientists? Some of those frameworks, I picked them up relatively quickly, but I just didn't have experience with them. And so I think anytime you, maybe it's an internship, but get the opportunity to, see how companies actually do data science at scale is huge. Creating analytics programs from scratch. So I work in consulting, and so a lot of the companies that I work for are pretty early in like the data maturity cycle. And so a lot of them, like I am the first data scientist. And so I've had to think about things like, how do you run a data science program? Not just how do you do data science, but like, how do you develop a use case portfolio of like, we have this data and these are our business objectives. How do we prioritize different data science problems? How do we assign return on investment to those problems? Things like that. So really building out like a corporate practice or a business practice of data science in a organization. So if you can start thinking about those types of things, you'll be like light years ahead of the person that is just really good at math, which there's nothing wrong with just being really good at math, but yeah, it's really more than that. Another thing is doing data science and dashboarding at scale. There's a huge difference between your professor like giving you a couple CSVs and you doing some sort of join between those CSVs inside of a Jupyter notebook, building out some model and spitting out some results. Like that's a huge skill, and that's a really big part of it. But if you're doing it at scale within an organization that has like a dev, a QA, and a production environment, and the data is way bigger than anything that can fit in a CSV, you can't do it locally on your machine. You have to spin up a cloud environment. Like those are other kind of things that are maybe tougher to learn in school, but super important for the job. And then again, this one might be specific to consulting, but putting together proposals. So again, I'm in consulting, so there might be a company where I know what they do, I know what data they have, and I have like a great plan for their life on how they could operationalize that data and use it to cut cost in their manufacturing process or whatever the case may be. But even if you're working internally, like let's say you get a job at Google as a data scientist, awesome job. You're still going to have to be able to like talk to different stakeholders in the business and say like, this is why this is an important problem. This is how I can, answer this question. And, you're going to have to be able to like document that and to get other people's approval and buy-in. And so that's something that like, again, I didn't learn in grad school, but I've just kind of had to learn on the job. So day to day, so this is actually like my day to day. So my current client's on East Coast time, I'm Central time. So I had an early morning meeting, 7:30 stand up, which that's just like a 15-minute meeting with me and some kind of adjacent people, some data engineers. And we just talk about what problems we're running into, what tasks we have for today, how are things going, what blockers do we have, what help do I need, what help do you need, that type of stuff. Then I've been doing some data engineering on this project as well. So I spent a lot of the morning doing data engineering. And so data engineering, it's kind of a tangential skill set, but it's like, so I've got data, let's say that it's a company that sells stuff on the internet. Okay, so they sell like home goods on the internet. This company might sell stuff through their Amazon store, but they might also have like their own website. They might also sell stuff on, I don't know, Best Buy. So I need to go out and be able to grab their sales data from all of those different systems, pull them into one place, and perform whatever analysis I'm going to do. So that's going to involve things like using Python to establish API connections, pull it into a data warehouse, then set up some SQL queries to be able to pull it from the warehouse into my model. So kind of data engineering. And then kind of throughout the day, updating stakeholders on like how projects are going or asking for help. Like today, I was running into an issue with an Amazon API. And so I was, reaching out to an engineer on that. So depending on the type of company you work for, I'm sorry, I'm getting kind of low on time, so I'll keep going. So after lunch, I was doing data science. So I'm currently working on a computer vision model that has optical character recognition. So it's a huge manufacturing company with like manufacturing facilities all over the US, and they're wanting to limit access to their facility using cameras where basically cars can and can't enter based on their license plate. And so I'm having to take like live stream video data, use optical character recognition to scan that license plate. And if they're allowed into the building, then like the gate opens. If they're not, then the gate doesn't open. And so I'm using Microsoft's Azure. They have a computer vision service that I'm coding a custom solution to do that. And so this is a little picture from another project where I'm using Azure Cognitive Services, and I'm feeding in this image and it's spitting out a result where in this case it's doing a couple things. It's like it's passing back to me labels from the picture. So it sees a cell phone, it sees a person, it sees a person, it sees a room. It automatically generates a description. So this description is a woman showing her phone to a child. And then it's also automatically doing some other tagging features. So sorry, I probably spent a little too much time on the early slides. I think we've got 8 minutes left, but I can stay here longer than that. You guys have any questions about data science in general or career pivoting, or I'm open for anything.
Cool. Thank you so much.
Yeah.
Yeah, so if you have questions, post those in the chat. And then maybe Will, you can take a second to look through those and see which ones you can answer. Feel comfortable answering. While you're posting those, first I just wanted to say thank you for being here, because you're forming like this data science community at CCSF. It's kind of a new community. And while you're typing your questions, just want to let you know in a month we're going to have another speaker. So Greg's going to be speaking. So Greg's an entrepreneur in San Francisco, and he works with like communication technology and like emergency and disaster response. And so he's going to kind of share like that, like how do you go from being an individual worker to like running a business, and how do you like, he took Math 108, so he got some of these basic data science skills, yet he's been a software developer for a long time. So he's going to talk about how that's kind of changed his thought process, and he's working on, you know, tackling some projects. Like he's thinking about the project or the problem of space debris, and how in space, you know, objects kind of stay up there for a long time. They orbit around the Earth, and so that's creating a lot of trash. And what do we do about it? So cool. Will, do you have any time to look at those questions?
Yeah, for sure. So question one, were you expected to have domain knowledge? Where did it go? I lost it when he stopped screen sharing, but it was something to the effect of, was I expected to have domain knowledge? So I would say that's huge, especially when you're trying to break in. If you're making a career pivot, like I had a weird resume for some of the jobs I was applying for. And so like because of that, I think that the domain knowledge of like, okay, I have a healthcare background, that helped them to kind of take a risk on me with it being my first data science job. So yeah, I think it definitely helps to have domain knowledge for sure. Let's see, besides regression and clustering, do you use time series analysis for your job as well? Yeah, absolutely. So like right now we're doing some like sales cycle modeling for a client and revenue forecasting. And so, yeah, lots of time series analysis for the revenue forecasting. And yeah, that's a great skill to have. I'd say anytime you have a chance to do a time series project, it's great for your resume. What was the data science job interview like? So I'd say in general, resume, sometimes cover letter. You have a first interview with kind of a generic human resources person. It's like a 30-minute, tell us about you, tell us about your resume. If that goes well, technical interview. So generally that's some sort of time limited coding challenge. What they'll send you a data set and they'll say, you know, predict outcome X or whatever. And then after that, there's generally some sort of on-site interview where you're like meeting the team, the people you would work with, who your direct report would be, that type of stuff. When you develop a data science program for a client, are you responsible for costing out the program? Do you build out scenarios for the client in terms of what level of data quality they can afford? So I love that because it gets at two things. One is like being realistic in the data science challenges that you're trying to tackle. Because yes, like I think unless you work for an employer with infinite cash, they're going to want to be able to quantify return on investment. How much is this going to cost upfront? And then what is the kind of time horizon for them recouping that investment? So yeah, I think that whether you're in consulting and you're doing that for another company, or if you're doing it for the company that you work for internally, you're going to have to be able to tie dollars to that. For whatever reason, I've found that companies are more willing to spend to increase revenue than to cut cost. Like, to me, it's like, what would I care if I bring in $100 more or spend $100 less? Like, on the net, it's the same. But for whatever reason, I find companies are more likely to do something to increase revenue than to cut cost. And then that question also gets onto data quality. That's a huge thing. I think that a lot of organizations aren't even ready for data science yet because they have huge data quality issues, whether that's they have bad data or they have inaccessible data or siloed data. Maybe it's a company that has 20 different systems. They have enterprise resource planning equipment, they have our software, they have accounting software, they have sales pipeline software like Salesforce or something, and they've got all these different disparate data sources and no data warehouse that has everything connected, where you could do some sort of research project across all of those technologies. So yeah, I think that before you pitch something, you have to understand things like data quality and data accessibility. Let's see here. Thanks for speaking today. 20 to 21 were good years for tech, but 22 has been brutal. With the wave of tech layoffs and hiring freezes, most recently Meta cutting 11,000 employees and Twitter cutting 3,700. What's your employee for the job outlook for a career in tech, at least in the near future? These massive layoffs have definitely induced career anxiety for students such as myself. So, this is a huge one. And, the Bay Area is super unique. Like, you guys have probably figured that out, but, the Bay Area is like chock full of companies that in a lot of cases aren't profitable yet, but have raised tons and tons and tons of cash and, are kind of at the revenue at any cost stage of the business cycle. And so that's great. But at the same time, I think that when macroeconomic conditions turn, you have a lot more layoffs at those types of companies. And so, I think especially in the Bay Area, it's brutal in tech right now. I think that it's probably not as bad yet nationwide. And I think that the tech sector is solid. Like, these macro conditions ebb and flow. Like, when I graduated high school or college, the 2009 global economic collapse had just happened. And 5 years later, the tech world's exploding again. So, I wouldn't be scared to be trying to enter tech right now. It could be a tough year for sure, but I think that tech will always be big just because it really does change the world at an entirely different scale than most other industries. How much of your job is cleaning up and transforming data? Ooh, that's a great question. A lot. I think the blog posts normally say 75% of a data scientist job is cleaning data. I think it's higher than that, honestly. Especially because I do a lot of the engineering side myself. And so I would say 90% of my job is moving data around, cleaning it, pre-processing it, versus building out models. Because really, model building and training, it's not super time intensive. Same with dashboards. If you're building out a dashboard, that's largely just drag and drop, but getting the data into a state where you can build a truthful and highly accurate dashboard or model, that takes a lot of time. Is SQL or Python used more in your job? I would say SQL, honestly, just because so many of those precursor steps are SQL, like moving data around, that's SQL. Building out new tables, that's SQL. Grabbing data from a data warehouse to build your model, that's SQL. Python, yeah, I certainly use it. I use Python and R, but I would say I code more in SQL. No one asked Python or R. That's like obviously the huge data science thing. They're both great. Like I have absolutely no preference. I'm yet to tackle a problem where you couldn't do it in either. And there's other great languages too. Is it fair to say that data analysis is a logical stepping stone towards data science, or are they different paths? I don't know. I'm not like a career guru. I can tell you like my experience. I guess I've seen lots of people that are data scientists now that were an analyst, like a data analyst before, where they're doing more maybe dashboarding and Excel work, and then eventually they get bumped up to more like model building. So I don't know. I'm not a career guru, but I would say if it's a job with a company that you really like and you like the teammates, and in the interview process, you can ask like, what's the career trajectory for a data analyst within your organization? Like, is there room to move into machine learning, data science? I think that's a pretty fair question.
Hey,
So
Will,
Sean,
I just wanted to pause and say, like, again, thank you. I'm happy to stay on for a few minutes if you want to keep answering questions, but I guess if we could all like give like a reactions clap for Will. So thanks for being here. Thanks for sharing with us. And like I said, I'm happy to stick around for a few more minutes if you want to keep answering questions, or if other people want to chat a little bit more. But thank you.
Professor Wickens, is it okay that I ask Will a last question and then the last question? I want to ask that. I want to ask Will.
Chifeng, I'll let Will go through the chat kind of in the order that makes sense for him. Is that okay?
Okay, sure. Got it. Thank you so much.
Yeah, thanks so much.
Yeah, I'm happy to stay on. Feel free to drop, obviously. Would you recommend me to specialize in Excel, SQL, Tableau, and Python, then skip learning C++ and Java? I don't know. Again, I can tell you my experience. I think they're all great. I don't know any C++ or Java. I'm sure that there are companies where that would be a prerequisite skill set, but to me, most data science job postings I see, it's more SQL and either Python or R. For a current undergrad student working on a data science degree, would you recommend grad school or going straight into industry? Honestly, I'd probably try to go into industry. Like, I don't know. Again, do whatever makes you happy and you think is a good career choice. But I think unless there's like a very specific industry that you're wanting to get into, so like if your dream is to work for Grammarly and build like predictive analytics around typing text, then maybe you get like some master's degree in like, I don't know, analytical, I don't even know what that would be, like analytical phonetics or something. But I think for like your kind of average data science job where you're like predicting revenue, like I don't know that you need an MBA degree to do something like that. What level of programming skill is required for an entry-level data science job? So I think that this depends on the company. I tell people this: when you feel really comfortable about being able to explain regression, and you feel really confident as a Python programmer, then start applying. Because like I I have this fear that people like are scared that they're going to get grilled over, the exact mechanisms of k-means clustering, and they never apply for a job because they constantly have this like fear that they're going to get grilled about some obscure form of math. And I would say start applying for jobs. Like when you really understand regression and can explain all the math and, are a reasonable Python and SQL programmer. Which Coursera or Udemy classes would you recommend to us? I don't know. I think that you're probably getting great teaching where you're at, but yeah, I think that the more education you can get, the better. My work uses DataCamp for like continuous education. So if there's like a new data science skill that we're trying to level up on as a team, we all have, it's like $10 a month, like it's super affordable. And so like I'll take a class on regular expressions in Python. So like how do I parse text better in Python? So I think that I don't have a specific course in mind, but I think some of those like $10 and $20 a month coding academies are great for like kind of learning that niche skill that, if you want to work at Uber, then maybe you take a class on route optimization. Like that makes sense to me. You might not find a route optimization class at your school, and it's $20.
Speaking of classes, Will was in my class when I was a grad student teacher.
Yes. So yeah, I really didn't start liking math until grad school. Again, I think it was just like the stars hadn't aligned for me yet. I didn't really understand all of the cool things that you could do in math and science. And so Sean was a grad student, I think, and he tutored me because I was not doing well in one of my math classes. And I kept showing up and he kept tutoring me and I got through. So let's see here. Any personal tips for trying to get started and getting your foot into the tech industry? I don't know. Be curious. I hate to use a Steve Jobs quote on a Bay Area data science talk, but it's so true. Like that's the first thing we look for in an applicant in our pool is like, how curious is this person? Like, are they the type of person that's going to go out there and figure out their own problems? Like, do they love this? Is it something they're really interested in? Because I think that interest can't be faked and people smell it. And that's like a great, like that gets your foot in the door. Like if someone can tell that you're just like legitimately curious about, how do I predict outcomes? How do I help a company get 10% better and predicting revenue? I think that's huge. I would say don't be afraid to reach out to people, but also be grateful if they reply. Like I think most people, if you reach out to them on LinkedIn in the right way, are probably everyone's been in a place where they need a break. I've certainly been in a place where I need a break. And so when someone reaches out to me and asks for career help or for me to tell them about what I do, like I'm going to try to make that happen. So I would say just be curious and be grateful when people are willing to take the time. Can explain regression and comfortable with a language like Python. What if we want to do obscure math? Is data science a good place for that? Absolutely. I wasn't trying to say obscure math like in a bad way. I think it's just like, again, not every company is going to have is going to be doing like neural networks to do, facial recognition for, something like that, or like route optimization. Like those are like specific forms of math that not every organization or company is going to need. But yeah, I think that if you're into like a very specific type of math, find a company that does that. I think, and I think niches are niches are kind of a double-edged sword because you're probably going to make more money in a niche field because you're a specialist, but it's also going to be kind of harder to find that first job potentially. So. How important is visualization in design? Is it a secondary consideration? I think for dashboarding, it's like a primary consideration. Like first consideration is the data that I'm displaying accurate? Because again, like companies have data quality issues, and like I've been at meetings where you'll have two executives show up with dashboards that have entirely different revenue numbers on them. And it's like, how does this occur? Like who's making these rogue dashboards that aren't even right? And so again, that comes down to like a corporate practice of data governance and some of these other types of things. But after like data accuracy, I think that visualization and design elements are like super important. If you're designing a dashboard, you know, how, what types of graphs are you using to display different types of data? Like there's a whole science to that. Even like color palettes, like there's whole sciences to that. Like not using blue and green in the same bar chart because it's like 30% of men are colorblind and can't tell the difference, and like obscure differences in blue and green. It's just like stuff like that that you'll learn kind of along the way. But I think that stuff is super important. I think I got through most of the questions. If anyone, if anyone has a last minute question, feel free to drop it in.
Yeah, or if you want to speak out, go ahead and raise your hand, and it's easier to speak it than.
Oh, yeah, sorry, I'll definitely answer this last one because it's huge. Is architecture design a big part of data science, or is it more of a senior level position? So architecture is huge. So like we have data architects in our group, and they're like world changers. Because again, like a lot of the companies I contract with are pretty early in the data maturity scale. So a lot of the like Bay Area tech companies are super advanced because, you know, think about like Google. I mean, Google didn't explode until like 2007. And so like they've only existed in the era of internet and the era of SQL database. So like they, from the start, were a data company. There's lots of companies that they're great companies, but they've been around for a really long time. And so they may have not, started with data science in mind. And so they're going to have all of those issues of like siloed data. And so I think that being able to warehouse solutions is huge. But that's probably not like a data science skill necessarily, but it's definitely an in-demand. Like that's the hardest job for us to hire right now is database architects.
Looks like you have a question, Andrew.
Yeah, I did. Thanks for doing this, Will.
Yeah.
Very, very appreciated. I wanted to ask specifically, you talked about math obviously being of importance and statistics, and I'm currently enrolled in a stats class at City College alongside Math 108. So some of the concepts that we cover in the last few weeks of class, we're going to talk about regression, we're going to talk about ANOVA analysis. So I just am curious, like I'm personally not planning on really probably doing any math classes beyond this. I already have an undergrad degree. I don't plan on getting a graduate degree. Is there anything that you use day in, day out that you think is like beyond the scope of an undergrad stats class that I could maybe pick and choose or try to dive into through YouTube videos, like other areas of math that are really important beyond an undergrad stats scope?
Yeah, good question. So the course I'm going to recommend is a course that I actually haven't taken. But 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 like linear algebra, like I've dabbled, I haven't taken the class, but I've read up on it. Like a lot of the like route optimization or just like optimizing based on a list of constraints. Like I think linear algebra for a lot of data science jobs would probably be super helpful. But again, I'm just talking from my personal experience.
Sure.
The guy you have on here,
Forgive my ignorance.
next week might have like some like other very important specific examples.
I was just going to follow up and ask, forgive my ignorance, but is that separate and distinct from just traditional algebra? I assume it is. Otherwise, I mean, it's a different thing altogether.
Yeah, Sean can explain it better, but it's more like matrix math.
Yeah, how in class we talk about NumPy being optimized for like array arithmetic. Like it's kind of like the theory of like vector, like thinking about like the lines, and vectors are a way of kind of representing lines.
Cool. Thank you.
All right.
All right. Any other last burning questions?
Hey, sir, I hope you don't mind. I joined a little late, and it might be a little off topic, but and you might not want to talk about it. But I was wondering how data science applies to cybersecurity or cyber warfare.
Yeah. So cybersecurity, and again, this is a little bit outside of my wheelhouse, but so like cybersecurity traditionally, I think has been like lots of like if then statements. So like, if someone, like if this IP address pings this directory, then alert trigger, something like that. But they're starting to infuse data science into a lot of cybersecurity platforms where it's like building profiles where like, Will's credentials, Will's IP address normally behaves in this way. If it starts behaving in another way, then flag, or, boot him out, send an error, whatever. And so they're going beyond just like static logic and starting to think and make decisions based on that. So yeah, I think machine learning is getting huge in cybersecurity. Cyber warfare, I know nothing about. So
Nah, fair enough. I understand. I appreciate that.
yeah.
All right. Well, thank you, everyone. It's great having you here, and yeah, thanks for building this community up. Will, I really appreciate you being here and kind of leading the talk and Q&A session.
Yeah, it was a blast. Thanks.
Yeah, I can get contacts later, but like if anyone wants to know more about Will or what he does, like drop an email in the message or send me your email or whatever, and I can pass it along.
Yeah, feel free to ping me on LinkedIn or yeah.
All right, thanks everyone.
Thank you.
Thanks. See ya.